So now I want to revise some symmetries that we have learnt before. So with our sine, cos and tan, we remember that sine of negative a equals to negative sine a. So this was an even function. And same with our tangent as well. So our tan of negative a equal to negative tan a. So the only exception there was that cos was a negative function. So cos of negative a equal to cos a. So similarly, since cos is our odd one out here, our cosine is also going to be our odd one out when we consider our odd functions. So remember, we've learnt this before, but just a little revision. With inverse functions, you can just take the negative out for both inverse sine and inverse tangent, but this is the only one that's different. So just be really careful of that. That inverse cosine of negative a equals to pi minus inverse cosine of a, okay? So this is once again the odd one out. So just be really careful. This is going to be pi minus inverse cosine of a. All right, so I think that's quite easy to remember because for both of them, cos is the one that we need to be careful of. All right, let's work with these symmetries with inverse functions now. So starting off with question 11, I want to find out the exact form of the tangent of inverse sine negative 2 on 3. Now, inverse sine of negative is quite easy in the way that we can just take out that negative. And because we have the tangent of a negative, based on our symmetries, we can just take that negative out as well, can't we? So now we just have negative tangent of this. So essentially, this portion here is exactly the same as the first couple of questions that we worked through. So we do exactly the same thing, the only difference is that there's a negative in front. So we want to make this input equal to x, and then we switch the input and output, and we change this inverse sine to sine. So we know that sine x equals to 2 on 3. Now from here, since we let that equal to x, I want to find out negative tan x, don't I? Which means I need to draw my triangle. So I know that sine x equals to 2, which is going to be your opposite on hypotenuse. Okay? So now you have that sine x equals to 2 on 3. So work out what this equals to, we just need to use our Pythagoras formula. Now, we just work out that that equals to square root 5. So tan x equals to 2 on square root 5. The only difference, as I said, was there's a negative sign. So this is going to equal to negative 2 on square root 5. Can you see that? So based on our right angled triangle, we've worked out that the exact value of this is negative 2 on square root 5. So exactly the same process. The only thing is, don't forget about your negative sign, which comes into consideration at the end. Otherwise, it's very similar. You just need to change this negative and take it out. Alright, so that was working with inverse sine of a negative value. In this question, we'll be working with inverse tan of a negative value. So, finding the exact value of cosine inverse tangent of negative square root 3 on 3. I can just take that negative out, yeah? And how did I get from this step to that step? So I want you to have a think about that before I let you know. So this doesn't look quite like an exact value, but how can I make it that? Well, square root 3, let's make the 3 on the bottom into square root 3 times 3. We can just cancel that, and that equals to 1 on square root 3, doesn't it? And inverse tan of 1 on square root 3 equals to pi on 6. So now we have cosine of negative pi on 6. And based on our symmetries, we know that that negative just goes. So cosine of a negative can just become cosine of the positive. So become cos pi on 6, which from your exact values equals to, exactly, square root 3 on 2. Yeah? So just remember that with your cosine, when you have a negative value here, it just becomes a positive. The other thing is to look out for your square root 3 on 3, because a lot of people don't initially recognize that it could be an exact value, but just think about that this is the same as 1 on square root 3. So whenever you see square root 3 on 3, just think about that as 1 on square root 3 and how you can apply that to your exact values. All right, great. So that was quite a nice and simple question. Let's have a look here now. So in question 13, we want to find the exact value for sine of inverse sine 3 on 4 plus inverse sine of negative 3 on 4. So first of all, we want to get rid of that negative, okay? First thing we want to do, get rid of the negative there. So we can just take that out, can't we? Because it's sine. So that just becomes inverse sine 3 on 4 minus inverse sine 3 on 4. What do we do from there? No, it's not a trick question. That just becomes 0. And we know that sine 0 equals a 0. All right? Great. Okay, what about this one now? We want to find the exact value of cosine, inverse cosine 3 on 5 plus inverse cosine negative 3 on 5. Now, I want to take that negative out, but I'm going to get very angry if you just take the negative out, because remember how I said inverse cosine was the one we had to be really careful of, because that negative, when to get rid of it, this becomes pi minus inverse cosine 3 on 5, all right? Really want you to just drill that into your minds. Inverse cosine of a negative becomes pi minus inverse cosine of that value. So this and that just cancel, and we get left with cos pi, which just equals to -1. So that's your answer there. So whenever you see inverse cosine, a little red light should be going off in your head being like, oh, it's not going to be the same as the other ones, it's going to be the one with a pi in it. Alright, so in question 15, we want to show that x times inverse tan x is an even function. So we haven't done even or odd functions for a little while. So can you tell me, how are we going to show that something's an even function? Yeah, that's right. We want to show that when we substitute in negative x, it gives you exactly the same function. So we start off by writing fx equals to this function here. And now we substitute in negative x. So we write f negative x equals to negative x tangent negative x. So wherever there is x, I'm substituting in negative x. Since this is inverse tangent, that means I can just take that negative out. So now I have negative x times negative of that. And then two negatives will multiply together to be a positive. So that just equals x times inverse tangent of x, which looks exactly the same as our original function, right? So therefore we can say that the function of negative x is equals to the original function. And once you've written that, you just need to write, therefore fx is even. Okay, so do you remember with odd functions, what it was is that your f negative x gave you the negative version of that. Okay, so to find odd or even functions, all we need to do is just substitute in negative x. And I think that's quite easy to remember. So you can see that with all of these things that we've learnt before, you can always apply inverse functions into it. So that's what we're learning here, is the algebra and the trigonometry we've learnt before, but this time with inverse functions.